Hello and welcome to another fun fact learning episode. Again, my name is Chinonso. In this episode, I'm going to be explaining special right triangles. We have two special right triangles. We have the 30, 60, 90 degrees special right triangle and then the 45, 45, 90 special right triangle. But in this particular episode, I'm going to be explaining the 30, 60, 90 special right triangle. So without any further ado, I'll just quickly explain how we derive the special right triangle, of course, the 30, 60, 90. So let's have an equilateral triangle. And we know that for an equilateral triangle, all the sides, the length of all the sides are equal, and that means that um, oh sorry, that also means that the angles are all equal, so we have 60. So this is let's assume that this is an equilateral triangle with all the sides being equal, and it therefore means that all the angles uh, are equal. So we have 60. We also have a 60 here, and then of course here 60. So that they add up to 180 degrees, which is the sum of the angles of any triangle. So in order to prove or demonstrate how we arrive at the special right triangle, the 30, 60, and the equivalent length of the sides, we want to divide these equilateral triangle into two right angle triangles. So, of course, drawing a straight line to divide this from the center through here gives us two right angle triangles. And of course, this is going to be 90 degrees. And then if this is 90, this is 60, we can expect that this would be this definitely will be 30 degrees. So having known that, we can also say that we want to give an equal length to all the sides of these equilateral triangles. So we can say that this is 2x, this is also 2x, and the whole of these would be 2x. That's from this end to this end. Then, since we've divided it into two equal parts, we can assume that this distance from here to here would be x. That would be 2x divided by 2. And having done that, we can as well say that, okay, since we know that this is an equilateral triangle. We know the length of the hypotenuse as 2x. We know the length of this side as x. We want to know the length of this side. So let's just name it y. So we can recall the Pythagoras theorem where we say hypotenuse squared is equal to opposite squared plus adjacent squared. So if you look at this carefully, the hypotenuse, so let's label these as A, B, and C. So the hypotenuse is the length AB. The opposite, now taking the angle 60 as a reference, the opposite is BC, and then the adjacent will be AC. So we are looking for Y, and then of course, Y is the opposite. So rearranging this, we can say that the opposite squared is equal to hypotenuse squared minus the adjacent squared. So we know that our opposite is, we've labeled it as y, which is equal to our hypotenuse. Now we say opposite is y. Our hypotenuse is 2x. So that would be 2x squared. Remember, this is squared. Okay, and then minus a, and our a is that's the adjacent, which is AC, which is x, so that would be x squared. Now that would be y squared is equal to, now squaring everything here, that would be 2, let's just say 4, so 2 squared is 4, and then x squared is x squared. minus, and then x squared, of course. And then they are like terms. For x squared minus x squared would be equal to 3x squared, and then so that would be y squared is equal to all that. And then in looking for y, we can take the square root of both sides, so that would be square root of y squared is equal to square root of all of these. And of course, square root of y squared is equal to y, which is equal to, of course, um, we can split this to be multiplied by square root of x squared. And then arriving at y is equal to, um, now the square root of x squared is x multiplied by the square root of 3, which we do not readily know. So that is the length of y. So for a special right angle triangle, we will draw our special right angle triangle here, the 30, 60, 90 degrees right angle triangle. So recall that this was 60 degrees, this was 30 degrees, and then these 90, of course. And we can recall that this is 2x, this was x, and this is sorry, x root. So that would be x root 3. And no, so now this is the rule. Um, the side opposite 30 degrees is half of the hypotenuse, and then so we're also going to know that the side opposite 60 degrees is x root 3. So whenever you see a right angle triangle such that you have one side being twice the other, and then one of it has this square root of 3 with a constant, which is the coefficient of the side, the shorter leg, know that you're dealing with a special right angle triangle. And of course, in our next episode, we'll also be looking at the 45, 45, 90 special right angle triangle. So this is the 30, 60, 90 special right angle triangle, and knowing the ratio of the sides accordingly. I hope this video is useful.